Okay, so up to this point, we've been just kind of doing the background on the topic, and we've been doing a little bit of the math. Now, let's start doing some physics. Okay, let's start solving some problems. What I'm going to do are the problems 217, 224, and 253 in your book. So let's take a look first at 217. I'm going to do parts A, B, C, D, and I for this. Okay, so this is chapter 2, number 17. It's on page 31. Okay, the position of a particle moving along an x-axis is given by x equals 12t squared. So I've got x as a function of time is equal to 12t squared minus 2t cubed. Okay, so now, those of you who are not calculus savvy, just go ahead and go to the calculus, go to the calculus presentation that I do on how to do some derivatives. We're going to hold off on how to do integrals. That's a bit more involved. So let's just take a look at what we have here. So now, I'm going to want to find the instantaneous velocity and instantaneous acceleration. So I need to take the derivative of position. So I know that velocity as a function of time, my instantaneous velocity, will equal the derivative of position as a function of time, dx dt. Okay. So now, the derivative of this is equal to 24t minus 6t squared. And my acceleration as a function of time is equal to the derivative of velocity as a function of time. Okay? And so my acceleration will equal 24 minus 12t. So now, parts A, B, and C, they want my position, velocity, acceleration at time t equals 3 seconds. So now, my position at 3 seconds, I just put that into my position here. I've got 12 times 9 minus 2. 3 cubed is going to be 27. Velocity at 3 seconds is going to equal 24 times t, which is 3, minus 6 times t squared, which is 9. By the way, this is 108 minus 54, so this is equal to 54. 4872 minus t4. This is 72 minus 54, 18. My acceleration as a function of time, okay, this is going to be 24 minus 12 times 3, so this will equal negative 12. Okay, so that's A, B, and C for number 17. Okay, part D, it's really B and E I'm going to find here. What is the maximum positive coordinate reached by the particle, and E, at what time is it reached? Okay, so now, in D and E, we're talking about a maximum. Now, here's the thing. Think about this. Take this pen, this little marker, I throw it up. If I say up is positive, okay, it starts off here, I'll call that 0. Goes up, comes back down. What happened? What quantity did we know when it was at its maximum position? What quantity do we know when it's at its maximum position? Okay, it goes up and down. Okay, it goes from up, which is a positive velocity, to down, which is a negative velocity. It has to go through 0 in the middle there. Okay, so now, when it's at a maximum position, okay, I know that the velocity has to equal 0. Or it's going to be at an endpoint. In other words, I throw this and I go off like that. You don't see where it lands. Okay? I don't know if you do or not. Let's just do this one. Let's do that over there. Okay? The maximum value you saw was when it was here. The only interval over which you could take any information about is when it's over here. Okay? And you know it's still going up. All right? So it's either at a point where the velocity is 0 or at an endpoint. So we have to take a look at those two conditions here. Okay? First of all, so I go get my marker. All right, there's really not an endpoint. It doesn't define for you an ending time. Okay, so we could take that as infinity. But if I make infinity its final point here, this becomes, okay, my t squared dominates. Okay, and so my velocity becomes more and more negative as time goes on. Okay, so in other words, my position versus time would start decreasing. So the maximum is not going to be at as t approaches infinity. So now we got to take a look at the other case where my velocity is going to equal 0. So now my velocity is equal to 24t minus 6t squared. And I want to set that equal to 0. I want to know where velocity is 0 because that's where I'm going to have a maximum position. So I do this, okay? And I solve for t. All right, I can factor out a t. So it's going to be 24 minus 6t is equal to 0. So now I can say it's at t equals 0, because if t equals 0, then velocity is 0. Or 4 seconds. So I have to check at 0 and 4 seconds. So now, let's take a look. So now, x of 0. At time t equals 0, I've got 12 times 0 minus 2 times 0 cubed. This is really squared. This is just 0. X of 4. This is going to be 12 times 4 squared minus 2 times 4 cubed. This will be 12 times 16 minus 2, 16 times 64. Okay. 162. So now 192 minus 128. Okay, so now at t equals 4, x is equal to 64. It's positive. So my maximum value is when is at t equals 4, and x therefore is equal to 64. Okay. Now, the last part there. Determine the average velocity of the particle between t equals 0 and t equals 3. Oh my gosh, I can't believe how many times I've asked a question like this on a test, and you guys always get it wrong. It'll be on your test. Don't get this wrong. At t equals 0, remember, average velocity, starting point, ending point, time it takes you to get there. Let's take a look. It's between 0 and 3 seconds. X of 0. Here, I'm just going to erase this because I don't need my velocity and my acceleration now. X of 0 is equal to 0. X of 3 is equal to 54. So my average velocity is delta x over delta t, which is 54 divided by 3, which is equal to 18. Done. You don't do anything with the velocity. You don't do any crazy calculus stuff with that. You do some crazy calculus stuff. But calculus is there to make your life easier, not harder, which sometimes you guys do. All right, problem number 24. An electric vehicle starts from rest and accelerates at a rate of 2 meters per second squared in a straight line. This is Chapter 2, number 24. at 2 meters per second squared in a straight line until it reaches 20 meters per second. The vehicle then slows at a constant rate of 1 meter per second squared until it stops. How much time elapses from start to stop? How far does vehicle travel? Does vehicle travel from start to stop? All right, so now, two 24 v0 is equal to 0. Acceleration is equal to 2 meters per second squared until it gets to a velocity of 20 meters per second. Then it goes from the acceleration will equal negative 1 meter per second squared because it's slowing down in the positive direction. My final velocity will equal 0. Oh, by the way, my initial velocity over this time period, so my velocity here is still 20 meters per second. Okay, so I want to figure out how far it goes. All right, so the easiest thing to do is to take a look at this and say, all right, let's figure out where I am until I get to here, and figure out where I am until I get to here. So now, a couple other things that are implied that you have to infer. Okay? Or at least figure out. What time are you, at what time are you going 20 meters per second? Well, the time that it takes to do that is going to be my change in velocity over the acceleration. So that's 20 meters per second over the 2 meters per second squared. So my time is equal to 10 seconds. So now, I have the acceleration, I have initial velocity, I have time. So my x is equal to, I can use big dog on this, 1/2 acceleration times time squared. My initial position is 0. My initial velocity is 0, so I cut off my big dog and made a little chihuahua. 1/2 acceleration is 2 meters per second squared. Time, which is 10 seconds. I am going to start carrying back units as we go through these problems more and more. 1/2 acceleration, which is, so that's 1, it's going to be 100. So x is equal to 100 meters. Well, now, I can use this. I can say, all right, x0 here is now going to be 100 meters. My initial velocity for this part is going to be 20 meters per second. My acceleration will be negative 1. My final velocity here is 0. I need that to figure out the time that it takes to do this. So now my time is equal to my change in velocity over the acceleration. My change in velocity is negative 20 meters per second over negative 1 meter per second squared. Just so you can see how the negatives work here. So my time is equal to 20 seconds. I think you guys could have figured that out, but I wanted you guys to see the negatives. So now I have to use big dog in all of its splendiferous glory. 1/2, my acceleration is negative 1 meter per second squared. My time is 20 seconds squared, plus my initial velocity, which is 20 meters per second for 20 seconds. Add in that 100 meters. So now I have x is equal to, this will be 400, negative 400, negative 200. So that's negative 200 from the acceleration part, plus 400 meters, plus 100 meters. So now x is equal to 200, 300 meters. Okay, I've gotten to 300 meters. What was the question asking again? Okay, a lot of times I just like to figure stuff out and then see where I go from there. How much time elapses from start to stop? Well, I started off, okay, the first part takes 10, second part takes 20, so that's t equals 30 seconds. Okay, and where are you relative? How far does the vehicle travel from start to stop? That's the 300 meters. Okay. 253. Water drips from the nozzle of a shower onto the floor 200 centimeters below. The drops fall at regular, equal intervals of time, not distance. The first drop striking the floor at the instant the fourth drop begins to fall. When the first drop strikes the floor, how far below the nozzle are the second and third drops? This is a nifty little question. Not that this is going to solve the world's energy crisis or anything else, but what this does do is make you visualize what's going on. So let's draw a picture. And you don't have to be good at art. I am awful. But I can at least get an idea of what I'm doing here. Okay? So now I've got my little nozzle here. I'll make it like one of those rain ones. See, I'm terrible. Okay, so now, down below here, I'm going to say that this is 2 meters instead of 200 centimeters. So 2 meters below this, okay, I've got the drop here, and I've got the drop here. In between, I've got 2 other drops. I'm going to assume that this drop is a little bit closer, and this drop is a little bit more towards the middle, but still a further drop. So now, here's my picture. All right? Over equal intervals of time, this is what happens. Okay? So now, this is the first interval, the second interval, the third interval. So there's 3 intervals of time that take place here. If I can figure out the time that it takes this drop to fall the full 2 meters, I can figure out how much time this one's been in the air, and how much time this one's been in the air. This one's been in the air for 1/3 of the time. This has been in the air for 2/3 of the time. Those are equal intervals of time, not equal intervals of distance. So now, I'll just go drop 0, drop 1, drop 2, drop 3. Drop 3 has fallen the full 2 meters. Initial velocity is 0. I'm going to make down positive. So I can just go x is equal to 1/2 at squared. Okay? You don't have to make up. Okay? You don't have to make up positive. You can make down positive. There's no reason why you can't. It helps eliminate some terms. So now, 1/2 at squared. So now this is going to equal 2 meters is equal to 1/2, 9.8 meters per second squared, times t squared. So now, solve for t. Again, that's algebra. You guys solve that now. Hit pause. 2 divided by 4.9. Answer. So now, this time is 0.639 seconds. So now, drop 2, well, drop 1 is going to be 1/3 that time. So I'll call this T3. T1 is going to be T3 divided by 3. So that's 0.213 seconds. So how far has it gone? Okay, then again, use the Chihuahua. 1/2, 9.8 meters per second squared, 0.213 seconds. Square it. X is equal to, okay, so that's squared. And I get 0.222 meters. Drop 2. Okay? Twice as much time as the other one. Huh? Okay. 0.639. Okay? So now, x, let's see, T2 will equal, well, 2T1, 0.426 seconds. So x2 is equal to 1/2, 9.8 meters per second squared, 0.426 seconds, squared. So now x2 is equal to squared times 0.426 each 9 meters. Okay? So in that first interval, you fall on 0.22. In that second interval, you fall on 0.667. In the third interval, okay, you fall, the other part is going to be 1.111 meters. Okay? I just want to make sure that that's the question that it's actually asking. 253. Okay, how far below the nozzle? Okay, so the answer that you're looking for is the 0.889 and the 0.222. Okay, hit pause. And that gets you through the first section. Again, if you need the calculus part, watch the calculus part before you do this.